Take it away.
Hi. Yesterday we have seen Python packages, R packages, and the main problem was always the performance and what we should do about the performance, and backing up with C++ or Rust or other compiled languages. But that brings a duality of languages. In general, you have to have a C++ developer and an R developer and Python developer. You might have case that one person can do both, but in statistics and machine learning domain, it's really rare. You don't see people that can do both at the same time. And so in that case, Julia become very handy. And now, why we need to use Julia? It's because it has a really high performance, and it uses JIT compiler, and it reaches the speed of C or Fortran, and without actually sacrificing the readability or convenience for the people who are developing it. And it's easy to learn. The syntax is a really high level, and it's very similar to Python, MATLAB, or R, and without actually, again, sacrificing development time and so on. And Julia has multiple dispatching and type flexibility, and that allows you write robust software and type safety within a functional or object-oriented framework. And why multiple dispatching is important, we have seen yesterday also combination of R6 objects, S3 objects, and different objects mixing up. But the goal is really writing software that is really coherent for the users, that they use, for example, forecast function that they can use for many different models. And sometimes you provide extra information such as external variables as a data frame or as a matrix. And for individual those function argument, you can provide a function that can process that, and that's what actually multi-dispatching is. And R does not have native multi-dispatching. However, single dispatching via S3, S4, or S7 object, and it has support for multiple dispatching via external packages such as S4 and S7. Even that is not really convenient. And Python uses single dispatching built into with func tools, and you can use single dispatching, but it's not a Python native framework. Even though Python is an object-oriented language, multiple dispatching is still relevant because objects in Python are simply using self as a single dispatching argument. And it helps for data science process to write really functional style workflow. And Julia also has built-in parallelization and high performance computing support, and you can seamlessly from CPU to GPU, you can deploy your execute your code anywhere you want. And one language for prototyping and production, and we saw yesterday we talked about C++ and other low-level language or compiled language to try to optimize their code. And yeah, those are the benefits of Julia. And I will also talk about now Julia forecasting ecosystem and only stat and econ, econometrics and statistics packages. And there is forecast.jl, it's inactive and have been 4 years, no commits or no changes. And even taking this code base was also not relevant for me. And I didn't want to build yet another package. I wanted to contribute some packages, but most of the things were not existing in this package. And another package was also ARIMA, and it was also not active, and for years no update, or the functionality was also very limited. And existing code was also not working. And our forecast was one of my projects, and I stopped developing it, and because I wanted to move to Durbyn, and yeah, it is at the moment it's inactive. And intermittent demand is also another package I started, but I stopped because I decided to develop Durbyn. It's also inactive. Those are the packages that are available on GitHub. And Storymax is a package. It's active, but the functionality is very limited and way slower than Durbyn package. And yeah, it's also functionality is very limited. I think the most comprehensive Julia package is state space models. It's active, it's under constant development, and it has ARIMA, ETS, and other models. It's based on time series analysis by state space models, but it is quite slow. We will see in the demo. And yeah, Durbyn, the name doesn't stand for Durbyn, the station. It's a Kurdish word that stands for pinnacles, and Dur means far, and B means to see. And yeah, it's a lightweight, modular, and fully Julia native framework for time series forecasting, designed with researchers, educators, and practitioners in mind. Combines clarity and computational power, offering rich suites for classical and statistical models within a clear and extensible architecture. We will later on look at the architecture too. And as I said, it's ideal for learning and teaching time series analysis, benchmarking and prototyping models, building custom solution. It's very, due to the Julia's high performance, and you can really build in large clusters, run in a really large cluster of machines. And it has a modular architecture and native Julia implementation, as I mentioned before. And there are modules in the Julia, one generic function models. It provides such as APIs such as forecast, plot, forecast types, and then models such as ETS, Holt-Winter, simple exponential smoothing, ARIMA, Proston, RR, and my forecasting, and intermittent demand forecasting model that is based on TS, intermittent, and stat and transformation module that is, we have box transformation and a decomposition and differencing and Fourier terms, and optimizer. I did not use the Julia's native Optim package because it was rather slow and performance was not so good. And at the moment, I just developed an algorithm from scratch. And later on, I will also integrate Kozin-Eponian optimizers to make it available. And some utility functions we have also for diagnosis and so on. And the syntax is very similar to R or any other package we have seen yesterday. You load the package, actually the module, and then there are the model, and create a forecast, and you can also plot. And yeah, let me just jump into. So I will compare, because I made a claim about state space models. Let's check if it's really true. And I'm just, since Julia is using just in-time compilation, sometimes loading the code, it takes some time, or running a code initially, it takes some time. For many people, it's strange. but that is partly comes from JIT compiler. And then we have state space model. And I'm just using the example in their README, and they use log air passenger, and then we will check the backgrounds. As I said, it takes some time until it loads, but when you run it second time, it's quite fast. Just but once it has been compiled, it's quite fast. And yeah, this is the air passenger data with log. As I said, from the original README file, I'm using that. And this is the original air passenger data without log transformation. The forecast looks rather strange. And let's look at the model they provided in README file. Since now it is compiled, it should be faster, but this is taking around 5.4 seconds. Keep that number in mind. And forecasting is rather quite fast. And then Sorima, this is also an example on their README, and I'm just using the same example. And it takes some time until you run the code. Initially, when you run the code, it needs to compile. And yeah, this is the model construction. It's very fast. Model fitting is also fast, but let's check the build. This is around 0.3 seconds. And then forecasting is also very fast. And I'm restarting the kernel and using again the data and loading the Durbyn package, exponent smoothing module. And we have ETS, and take some time until it compiles. And this is the log model as in state space model they provided in their README, and the forecast looks very similar. And this is the model where I use the same. So air passenger without any transformation. It provides some same model as our forecast ETS. And although the parameters are a bit different. And so the state space model ETS was around 5 seconds, and this is 0.6 seconds, and it's a lot faster. And when you think about thousands of time series, that's a substantial increase. And that's why I did not want to actually wrap that package and create implementation of it for data frame interface. And later we will talk about it. That's one of the roadmap topic. And yeah, forecast is also quite fast, and plotting is also. And let's look at the ARIMA. The state space models, ARIMA was 0.3 seconds. And let's run the same model here. Yeah, the compilation for, you can see that ARIMA model has been built in a fraction of that time. And it's perfect base for auto ARIMA. I haven't wrote it yet, but that would be the base for auto ARIMA functionality. And even you fit 1,000 models, it will be faster than the single model from state space model. And yeah, so that's the comparison with state space models. But let's look at also the functionality. I will not run the whole code, but just want to go through. an exponential smoothing module. We have so ETS and simple exponential smoothing. It's anyway when you have ETS and all others are just products of it. And then holds, hold winter. And for intermittent demand, I have a different implementation. One is based on SES, and Rob and co-author showed that actually Crossen has a process of running two different simple exponential smoothing. And then I have specifically intermittent demand model based on Nico's work. And there I have classical Crossen method. This code will be updated where I will have similar methodology as here, one model fitting and then forecasting functionality. This I haven't done it. I just import the code from the initial package I had earlier developed 3 years ago. And then one approximation. And yeah, and then ARIMA, we saw it, AutoARIMA will be developed and syntax will be very similar to our AutoARIMA. I haven't developed it yet. And our model, I don't know if you have heard it or used it before. And it's quite a efficient model, especially when there is a clear autoregression. And I'm also now developing a new version of it where there will be a moving average component, and that to come. And yeah, that is at the moment current functionality of Durbyn. And so yeah, there's a roadmap for Durbyn, and the preview is that we will first develop a data frame interface similar to our Fable, and I hope I will convince Mitch and Rob to contribute, and also hardware agnostic and support where you can run the code on GPU or CPU, because you can do that in Julia. And I don't have so much time, so I would just skip these 2 slides. And the advantage that you will run the code on GPU and CPU. And I will just go right away to live demo, how this can be done. And it's actually quite straightforward. And let me restart my kernel. It doesn't mess up CUDA. And completion takes some time. And so this is a function that computes phi as it's a parameter in our function. And original code look like this. But as you can see here, the dot product from statistic package is not able to process the GPU array. So you need to run it I had to rewrite it in a way that can process the GPU arrays. And so I'm just I would just use air passenger data from Durbyn package, and first convert the air passenger data into CUDA array. And as I said, CUDA is a large package. Pre-compilation takes some time, but when it is compiled, you can rerun it, then it's very fast. And especially in multi-threading, it's extremely fast in that case. And if I rerun it again, as you can see, it doesn't even take a second. And one cool thing about Julia, you can write LaTeX equations as they are. As you can see here, I use phi as we typically see in LaTeX documents. That's pretty cool, and does not really affect the performance. And as you can see here, is the input data is a GPU array, and output is also a GPU array. Here, the input data is a normal vector. The output is also normal vector. And you can process the same code. Just you need to really think about writing the right way that you can process the data with same functions and so on. And you can also write different function. I could also use this function and reformulate. And for normal arrays, I could use this function. And for GPU arrays, use this function. And I would call it simply just compute fee. And it would be the same way. And so that is about hardware agnostic part. And Julia can support hardware agnostic programming because of the multiple dispatching and strong typing system, and very similar to other professional software languages like Java, C++, and Rust, where you have ease of programming at the same time as speed. And this package won't be released at TOPS. TOPS stands for Time Series Analysis and Forecasting Society. It's a Vienna-based nonprofit organization, and its mission is connecting researchers and students and practitioners and learn from each other. We have also done some lectures and share the knowledge, and that will be part of it, and innovate together and create a forecasting ecosystem for users. And yeah, I believe that open source as a philosophy and not a product strategy, true open source is about freedom, transparency, and community building. And corporate-led projects may use open source licenses, but their goal is really monetizing and not community growth. Maybe they want to also build a community, but not really keep it forever open. And control, not collaborate, because when you want to make a contribution to a corporate-led open source, you most of the time need to sign an NDA or something like this. You give really intellectual property to this organization. I find that not really a good way for open source projects. And yeah, it's an illusion of openness, but it's not really open governance. And that is also quite important, in my opinion, for open source projects. And that said, it's also projects that are only from individuals that are using having their own repositories and providing code for users. That is also not a sustainable way. And if these people find another project or some another job where busy, they will not be able to maintain an organization. Proof organization needed very much for the open source projects. And we had some examples. We are all forecasters, and I think everyone has some autoregressive process built in their brain. So when you look at history, there was Elastic and was initially Apache license, and then they changed the license, and then Amazon forked it, and there was MongoDB also open, and then they changed the license. It was quite a disaster actually for the many developers who used that packaging, this database in their projects. And why did open nonprofit organizations so important? Because they don't have any intention to change the licenses, and that provides a community governance, and you control your projects and you sustain it by yourself. And I'm not saying that it should be tough. It can be forecast for social good for some other institution, and that our code is taken care and provided to the public, and avoiding pitfalls of the corporate control. And we have seen previous examples. Today is open, but tomorrow is not, and those things happening often in the open source projects. Yeah, thank you. Was right.
Thank you, Resul. My name is Fia. After the discussions, I do have a little slide, but I don't want to get to it without addressing your burning questions first. So please, if anyone has any questions.
Yeah, maybe another question in compilation. So do you need to recompile to change the essence? To recompile to change the units? Or does it like
compile? So no, it's just compiles and it's when it goes to the line. It's similar to compile, but it's naked.
So, I mean, the elephant in the room, I think, is the maturity of the ecosystem for the things with it. So, what is your perspective? Can you do anything that you like?
Yeah, definitely. I mean, of course, there is work to be done. We need to develop it. It's not everything out the box is there, and but we can do anything that we have done in R.
What I mean is in terms of maybe a hypothesis test. I'm not suggesting
Yeah.
all of these hypothesis tests in some series. Or...
Yeah, such things are quite stable.
Okay.
And it's used a lot in physical processing, in engineering. It really replaces MATLAB a lot.
I'm trying to include tendency to use machine learning models.
And maybe not in this package. Maybe it can be another version, or don't want to have too much dependency. I don't know. I don't want to be deciding everything. I hope the community decides. That's the idea. If the community sees as a fit, we can.
I was curious to hear the perspective on in which situations is hardware agnostic for the GPU acceleration. Most of the small pieces this for us.
In case of that, you have a really large data set and you would like to deploy it in large cluster of machines, and then you can use, instead of having 90 or 200 cores as machine, you can have a 1 GPU and running. And I haven't tested how much will increase or decrease the core costs and time, that to be seen. But basically, and you have multi-threading, we can easily do it. It's really Julia native. If you have, for example, ETS function and yeah, you can just put their threads and then it is distributed. It's really not in hard that you need to create a cluster and then distribute in another package and so on. It's really native, everything. And when it comes to the deploying CPU and GPU, the framework that I'm thinking somehow would mimic Bubble would be different constructions. For example, you could have such a modular construction and provide a data frame and then group for ID index and automatically filling the gaps. And if you want to have a balanced panel data or not balanced panel data, so this is only a proposal. I haven't built with this function. This is just a function definition. And then you can provide another formulation, provide a data frame. And this is also a good example of multi-dispatching. And then you have another construction creating a time series data and could be a data frame. You have response variable, you have group variable, static variable, dynamic variables, or you provide an integer there and specifying those, and then, or you have a matrix that you don't have to use a data frame, because data frame is just a starting point. Tony said, I don't want that spreadsheet in my algorithm. That is just for convenience of the users, and that is only will convert the data into vectors or GPU arrays. If your hardware having a CUDA, it will turn into a CUDA array and process it accordingly.
Key control is that I'm curious whether you can, let's say, so with the GPU, you want to do batching, right?
Yeah.
Are we able to batch over, let's say, AR2 and AR5 model? I estimate them in the same.
That's to be so. Investigator. And
Very fast in case we have an opinion. I think one of the advantages of Julia with Python, it's the real parallelism in it is not possible in Python right now, but Python community is working on that. Like, so now it's optional not to have GL. Do you think if Python ecosystem is able to remove the GL by default and it can be possible that we are in this area? The advantage will somehow be used, or you still think that make it idea?
I don't know if Julia will keep on growing, but definitely multi-threading. If they develop in Python, they need to change a lot of components in the language structure, and I think that will be again quite a breaking change, like from Python 2 to Python 3, and I don't know good path to maintain that, because I know companies are still maintaining or moving from Python 2 to Python 3 because this company broke everything. And I think we can ask that to Tony. Software engineers can answer that better, but without really this inherent problem of Python, I don't think it's possible.
Any other questions? Okay, Shuji.
Yeah, by the way, the code is not available. At the moment, only Mitch has access. I don't feel it good to release the code, because yes, I convert that to Julia, but really it's 25 years of Rob's work and Mitch and all other PhD students I've been working with. Them, without their approval, I will not release it.
You have my approval. The only reason why I suggest keeping it private is if you're going to make a lot of breaking changes, if you're not sure about the design yet. Other than that, work in the open.
Yeah.
What do you think?
And also, excuse me?
If you're going to make more changes that are breaking code, or other reasons behind keeping it private?
One reason is the licenses I need to clarify, because forecast package is a GPL license, and when I don't know if it means taking this code as a base and writing in another language means copying it, then I need also release it as a GPL.
Or you get permission from the copyright owner, which is me.
So Rob might issue you an MIT license.
And exactly, that's all. But it will be typical Julia license. It will be MIT license, and also I would like to build a strong foundation that ensure any future contributors that their work will stay in a non-profit and will not be taken by any other company, or the license will.
Nice. I'm sure we can talk about it after
Yeah.
the licensing. Okay.
All right. And so okay. And proceed to fix this. So I have limited example experience with Julia, so I'm just picking the keywords that feel that's caught my attention. So now I've learned it's very fast. It has native support of multiple dispatch. It has built-in parallelization, and for no okay again. For Durbyn, it's very impressive. So it's fast. It has more models and methods than other package, which means I can happily disagree that this is probably the best Julia forecasting package, both in terms of performance and in scope, when it's more final finished. And it's a hardware agnostic, maybe not for now, but it's the future. That is it. Okay. So most of my questions has been addressed already. I guess the name Derby, but I do have a question for you because from what I learned from Julia packages, my impression is that the name of the package are usually very explicit. Like there's no acronyms, it's just one word describing what it does.
Yeah.
But for this one, people who doesn't speak Turkish wouldn't know what it is without explaining it. Do you think this is going to be a problem when promoting or marketing or allowing more people to use?
I don't know. I mean, I'm Kurdish, so my people are really so less presented in scientific community, and I just wanted to bring something as a Kurdish name. That's it. That was the reason.
Yeah.
I mean, if the community doesn't agree with the name, we can talk.
No, learn a bit more Kurdish.
And it's fine for me. It's really not so strict. It's a review. I would like that comes into a comment.
And next question is, I think this is a very big issue because for now, people are reluctant to even use RE production, even though there are many ways and like material ways to do that. How would you motivate or but why companies to make this switch to
Any forecast, any software engineer would prefer Geo over Python and or Java over Python if there are the functionality. And yeah, I'm not talking about data scientists, but you ask software engineers, and it has all properties of typical software engineering projects and typical software engineering languages, and it's different than Python.
how much is Julia represented sort of used currently in industries?
It's mainly at the moment in research, especially in engineering, simulation, physical processes, such domains. And statistical packages are coming just by nature, and it's very similar to R. And most of the statistical packages are provided within the base package. You don't have to have an external package to use those. And yeah,
So that's
very much the nature of the base infrastructure is very similar to ArcStat.
Yeah. And you mentioned you didn't really go through the hardware agnostic part, apart from using it can apply on both CPU and GPU. But I imagine that can also be achieved to some extent in other languages. What would you say, for example, the difference between Julia and other languages, and how would not being able to have hardware agnostic features be a problem in?
We can have hardware agnostic also in Python, but then you need to have a CUDA code to write it and then port it in Python. And you need to have C for normal CPU. And then if you're using Mattel, you need to also have Mattel software to write for other, and or if you have, I don't know, Apple Silicon, and you need to have software for that and write it in that language and port it. It's just too much work. And you don't have to, with Julia, you don't have to write all those things by yourself. It's just provided via just-in-time compilation and compile code specifically for CUDA or CQ or other GPU.
Yeah. And my last question is coming up. Yes, when will it be out? And I guess you also answered the question.
Yeah. When I got the approval, and also fix somehow refactor the Arima code, and I need to refactor that. And when I finalize those Arima, should be done in the summer. But
Thank you very much. I think we're running out of time.